5 minutes. Okay, so lesson 5, 6, and 7 is our goal today. It shouldn't be too bad. Anytime, wait for it to pop up. Anytime we're doing, 2 or 3 lessons, it's not because we're trying to cram a bunch in. It has to do with how much material there is, and load up this, and I'll go like that, and we are good to go. All right, so those of you here were here last time heard my plea to be here next class. On Wednesday, we are starting Create Task, which is a lot of explanation, some practice, some, like, the project's going to be a bunch of small assignments, sort of like its own unit, except, the whole thing leads to something. But that first day is a great day to be here. As far as this current lesson 5, 6, and 7, we're going to talk about libraries, which are sort of like quality of life mods that they're like generally return functions that are super generalized that you can use for multiple apps and sort of work in the background. And it's actually a super common way to use these things, and we'll talk about it. But we have a nearly 3-minute video from code, and please pay attention.
Hi, my name is Ariana, and I'm going to show you how to use the libraries tool in AppLab. Once you've written a library like the one I have here, click on the Share button at the top left. Then click on Show Advanced Options, and then toggle over to Share as Library. Click the Share as Library button at the bottom of the pop-up. Next, erase the name under library name and give your library a meaningful name. I'll name mine List Operations, one word. You'll also need to give your library a description. I'll write functions to manipulate lists. Under functions, you can select all or just select certain functions. I'm going to select them all. You'll notice my multiply by function doesn't have a comment, so I can't add it. So make sure you give all of your functions comments first. Now I'll click Publish. You can copy this ID to share with anyone else or share with specific people, but I'm also going to show you how to view any libraries from your class. Now that we've published, let's check out how to access someone else's library and import it into your program. To pull someone else's library, click on the gray gear next to the word Toolbox, and then click on Manage Libraries. You should see any libraries you've created as well as others from your class under Import Library from my class. To add a library to the program, simply click on the plus button. Now, when I go to the Functions tab, I can see my library down here. There's just those 2 functions you saw, and when you hover over them, you can see how the comments show up. That's why my function without comments didn't make it. If you decide you don't want to use that library in your project anymore, click on the gray gear again, and then Manage Libraries. Find your library, and then remove it by clicking on the trash can. If you decide you also don't want to have other people using your library, you can go back to where you created your library and then publish it. I'll click on the Share button, then Show Advanced Options, toggle over to Share Library, and click the Share Library button. Finally, I'll scroll down in the pop-up box and click Unpublish, which will make it so that it's not shared with anyone anymore.
All right, so let's go ahead and talk about the libraries. So a lot of that video was about how to operate them in, you guys can turn your screens back on, those of you who turned them off. Okay, so lesson 5, the only deliverable is a check for understanding, which I think we need to, we might need to come back. Wait, hold on. Did I not? Lesson 5, lesson 5. Can you guys get to the, do you all see lesson 5? Why, that's really weird. Okay, so I guess I just have to. Like, I'm in this section. That's weird. Okay, so question is, evaluate the following function, see if is it a good candidate to be placed in the library, why or why not? I actually don't expect that 2-minute video to be enough so far. We will talk about that, and this whole, everything from 5, 6, and 7 are sort of, for our purposes, the same lesson. So we can come back to it and work on it afterwards. So let's go ahead, or once you feel comfortable to answer, go ahead, let's refresh and go to lesson 6, and we will take a look at some apps that use libraries. Okay, first of all, you can see that a library is being used here, not because this word says library, but because there are these custom functions. And if you look inside the function tab, you can see there are these extra functions that are specific to this program or to any sort of the states table, anything that's using that. And yeah, so the whole idea is writing functions and not needing them in your app specifically, but also being able to use them elsewhere in the same fashion. Okay, so let's run this program, read how the code runs. Let's see here, try several inputs. Okay, discuss the question with us. Okay, let's do we have to type it specifically or case sensitive? As I let people in. Yeah, so do we? Okay, so you type in a state name and you get its result. We have done similar stuff with using the table before, where you search, one column and get the matches from all the other columns. Okay, open the functions drawer, CLE, mouse over documentation. Okay, click manage libraries. And we will be able to view the code. Okay, and this is, why are there so many? Why? Okay, those are, I guess that's teacher specific. Okay, so this is what the code looks like in the library. And, oh wait, did I not have it? I can put it up on the back, excuse me. I just realized. There we go. Okay, the code that is the library looks like this, and this is all just functions. Okay, it's functions with no like script, no program that ties them together. They're not being called at all. And if you were to copy it into the existing thing, it would probably look more familiar in block mode. So everything below here is what it looks like in the code. Okay, all these functions already written, okay, but specifically for the states table. Okay, and the returns are, oh, okay. So I talked about this briefly when we were talking about return statements. This is an aside. A function can have 2 return calls in the same thing. The thing is, it means wherever that return gets run the first time, which, excuse me, this is in a conditional that might never come true. But if it does eventually come true as it loops through this list, that's what happens, and it ends the function. Like, it doesn't keep looping. And this alternative, this is if they never get a match, this is what pops out. This doesn't need to be in an else, because it would only get there if all of these failed. But more on return stuff later. We have, what do these functions do? We have, which of course we can look at. So what I just did where I copied the functions from the library in is the whole point that you don't need to do that. I just wanted you to be able to see what this code looks like in AppLab form. This is just, of course, text mode. But the idea is those are all saved and accessible from wherever, including other apps. Like that's sort of the point is you write some functions that are useful in a very generalized fashion. And if they're generalized enough, they're useful all over the place. Okay, see how it works. Click on Manage Library, view code, read the code. How do they function? Were your predictions correct? So there's not any real deliverables here. The functions are just being called the functions that are in the library, or the function calls are accessing the ones that aren't, present in this program code. They're being referenced. Okay. And all this program code should look familiar and be able to figure out what's going on, especially since there is literally a comment. We do need comments for our functions, especially anything that has a return or a parameter. It's not reasonable to just write your code like that and expect to understand someone else to understand it, or for you in the future to understand it. It's a definitely best practice. Okay, so that's our first look at libraries. Let's go to Bubble 2 from the same unit. Okay, run the program, read the code, and try different inputs. Discuss with a partner, prepare, functions drawer, strings library. Okay, so let's look at the actual program and the library. Okay, it already has this bubble, lesson 6, bubble 2. Wait, yeah, 6.2 is strings about, or excuse me, functions about strings, which you don't, like the whole point is you don't have to copy it in, but I do think it's a lot easier to see what's going on. So the functions that are in the library are here in the functions bar, so you can just drag them out. And let's see here, first letter, all but first, has val, and split string by space. Okay, so when the button is clicked, okay, so let's see what happens. Okay, so it's clearly doing of course it's doing the Pig Latin thing, but Pig Latin is just manipulating strings, at least from a programming standpoint. And all of the rules for Pig Latin are addressed here in checking for string length and vowels, and splitting and reconcatenating the front at the end. Okay, and what are we actually supposed to do here? Okay, console log statement, end of the program, and call a function, put a reasonable argument in the space for the parameter, for example. Yeah, okay, so you can, of course, always test like you can anything else. Test the functions as you're programming with the console log statements. But for now, it's already written, so there's not really testing. It's just seeing what's going on. And so we run it, and we have an output of the first letter as this library function is supposed to return. We've done console log before, and I don't know, this whole series of lessons is really just to introduce libraries as a whole. The point of libraries isn't, it's like it already exists kind of situation. We're going to write some here in a minute, but there aren't a ton of deliverables for this. Okay, test the rest of the functions. What did you expect? Several different inputs. Okay, so let's have a console log statement for each of them. and we'll just run them all at the same time. Okay, so we have how many different, I think we have 4 different library functions imported. All but first letter. No, wait, that's first letter. All but first letter. Why can't I get it? Why is it not working? Why not all but first letter? Why is that not? That doesn't make sense. Is anybody else having issues dragging function calls? Really weird. I mean, I can't imagine it not copy and pasting in there. And str. Oh, we have to give it the input. That is where it says str, that's saying which string, which we don't have a string in there. Okay, that is when it is in the functions toolbar, it's whatever is whatever the parameters for this function is what we have to give it. Okay, and just a second. And is that working? Good. Okay, so we really, I mean, I don't know. Has val. Okay, so this is getting frustrating. I do want you to try these with different inputs, but I really think there's more value in looking at how the functions work, but there's that. I don't need this semicolon. Let's go like this. Okay, and the second to last one has val. You can kind of tell by the function name that it's a Boolean, or it's going to return a Boolean. Let's put some stuff in here. And geez. There we go. And last one in quotes. Why did that's so weird? Okay, and so we run this. And okay, then we have, okay, split string by space. What does that do? Well, I guess we could just mouse over and see what it does. Okay, so this split, well, has val is a Boolean function, or it returns a true or false, which means you would use it as a conditional. And the other one is doing regex, or regular expression. It's splitting the string wherever there's a space. It's turning it into a list split by string, which is actually kind of a complicated situation. Let's see how that works. Split by string is Pigify is the main program. Oh wait, of course, split by string would be in the library. Okay, show code. Is it just going to go to this? Split by string. I want to bring this into the code so that we can appreciate what it looks like in block form. Okay, split by string. In our standard return situation, we have a empty list and an empty string as our potential output. What it actually returns is the temp list, which, hold on a second, let's get the comments because that's sort of the point. Split by string, I should have grabbed those. There we go. And I go like this. And where are we? Right there. There we go. Okay, and is it working? Is it working? There we go. Okay, so it splits a string into a list of words. The input is a string, and the output is a list with each element containing one word. Okay, it goes through the entire length. if a position is a space, it puts the temp word, which is a blank. Wait, no, temp word. How is it getting? Oh, if it's a space, it makes temp word an empty spot, and then we concat whatever that element is to the end of the list. And we end up with a list of however many spaces there are. Oh, wait, I gotta do, no, it should be spaces in between, excuse me. Space, space, there we go. Okay, and am I missing a? Why, what am I missing? Open, close. That goes to that one. What am I missing? Hold on a second, folks. Give me a second. ASDF. I have the right number of parentheses or what am I missing? Sorry, folks. What is going on? What? Because why? You know what? It might be, yeah, I think it's probably because it's in, no, that doesn't make sense. From line 49. Yeah, instead saw, expect to identify. It doesn't make any sense. All right, well, either way, this function is in the library, which means we don't really need to bring it. Oh, that's the, of course, yeah, that's the definition. What am I doing? Okay, so we need, instead of, I don't, it's early. Okay, so we want split by, we want to call split by string, which of course is not popping in the way we'd like. So instead of message, there's a lot of work to not have something work. Am I still missing a close parentheses? I am. Okay, so this is just a function call to a function definition that is not in the code right now. It's in the library. And the way this particular one works, put there we go. And it should return those as a list. Yeah, with 3 separate things. Okay, and I think that was it for this one. Oh, okay, rules of pig Latins and so on. Okay, let's go to the check for understanding. The next lesson will have. Why is this? Make any sense? The stupid access. Okay, so here we go. Okay, why is it important to use meaningful names for your functions in your library? We've been talking about that since day one, or day one of functions, I should say. And go ahead and answer that, and we will move on shortly. Why is this so ridiculous every day? And okay, let's go to lesson 7 where we get a little more practice, as it says there. Okay, so go ahead and hit refresh. Okay, this program uses the states library from the previous lesson. You'll need to finish the app by writing the code inside the new state function by using the functions in the states library. You'll need to pick a random state, set the value of current state to that state name, and update flag on the screen with that state. All right, so we have a function right here that is in the program. This is not a library function. It's going to use the library functions from that are already built in because of the library. And if you're not sure how they work, this is a point to use mouse over on the definitions, or excuse me, on the function calls in the box. Tells you everything that you need. Well, this is where you see the actual comments. And if you want to see specifically, you can go to show code. Okay, so what you need to do here, as says in the instructions, okay, first pick a random state, set the value of current state to that state name, and update the flag on the screen to be that state. Okay, go ahead and give it a shot. Give you a couple minutes to make it happen and work through. Okay. You will need to use the library functions. Okay. I want to make sure we get done in a reasonable time. Let's just go ahead and take a look at this. Okay, pick a random state, set the current value of current state to that state name, which I think they could probably write in a single line. Okay, current state is a global variable, so we don't need to redeclare it, but we are going to reassign it whatever we get back from our function call to random state. Okay, this function random state just returns one of the states at random. How does it do it? I don't know, but it doesn't matter. Okay, theoretically, you would have written this function and you could say, how does it work? I forget, but it doesn't matter. Okay, this function returns one of the states at random. All right, and our job with that random one is update the flag on the screen to be that state. Okay, so state flag, well, we want to update, so we want to set a property, or I guess it's image URL, but set property always works. How does it do that? Set property, and the element is called flag image, and the property is the image property. And we want to set it to whatever gets returned from the state flag function. And what state do we want? We want current state. Okay, so current state is used as the parameter for state flag. You can mouse over and say, okay, returns the flag of a given state. Okay, the input is the name of the state as a string, and it returns a string. That's the image URL. Okay, so you know it works as a parameter for the set property. This entire function call, this return function call, becomes the string that is the image address, or it's probably a code.org database or server, but it's always nice when they have the name on there. Isn't okay? And it there you go. So this new state function using even is a new state is a lower level function. Well, it's part of this main thing. It's not part of the main program, the guest button thing, but it's using even lower level functions from the library. Okay, this abstraction. Abstraction is managing complexity. It's simplification. It's solving one problem and then not worrying about how it works anymore because you solved it. You just get to use it. That is a library. Okay, that is a description of a library. Okay, should be kind of easy. You may not have thought about doing it this way, but I think a lot of you seeing this are probably, it's dawning on you how you use return functions in place. Okay, so let's go on to bubble 2 and take a look at that one. What's up? And we're back. Okay, a simple program. This simple program should show a random cat and the name of the breed every time the user clicks a button. The library called cats has been added to the program to help read the documentation for each function in the cats library, which is a funny sentence. Use the provided functions to finish building the app. The user should see a new random cat and breed a picture every time they do that. Okay, so all we have is a next button that's going to do something. Let's look at what they've given us. Okay, we've got random breed. Okay, just like random state, it doesn't even receive a parameter. It's just going to pick something from the table, which is already been imported. Then there's breed image, where we put the name of any breed, and it returns the image URL, just like the last one. Okay, all breeds returns a list, the entire list of breeds, and random image is a returns the URL of a random cat image. Okay, so let's see here. This should all right, well, it's the same basic thing as before. Okay, pick a random cat and set the text and set the image to that. Set the text to whatever I'll just describe it verbally. Okay. You need to pick a random cat, set the text to whichever cat you picked, and set the image URL to the image of that cat. It's almost identical. It's super identical to the most previous one we did with these states. Okay, go ahead. This is like a 1 minute situation. All right, so just like the previous one, we need a random cat. So we'll just declare rand cat. And in order to get a random cat, we're just going to assign it cats dot random breed. Okay, open close parentheses, you know it's a function, which you don't even have to type. So we have a random cat. We need to set the elements here. Let's set a text of the text area called breed name, and we're going to set that text to whatever whatever was returned and given to rand cat. And I mean, just to make sure everything's getting to the right place. There we go. It's getting there. And then we need to set the image to that, which do we have set image? We don't. We have set property of cat image, great name for it. And we want to set its image property, and we want to set it to whatever gets returned for cat breed image. And we want it of rand cat. Okay, no quotes, of course, it is a variable. And it doesn't, nothing happens right away. Okay, so just go ahead and do this. It's not in the instructions, but it really bugs me when you hit go on a program and it doesn't go. So the way we would do this is, assuming it could run at full speed, is write a function called, called anything, new cat, and all of this stuff can go into new cat, and then we just call new cat inside the button, and we call it to run right at the beginning so that we can do it both places. And we hit go now, and I know, hypothetically that should run instantly or nearly, but a slight improvement, do that. That's a good picture. Less good. Okay, so there you go. We've written a function that accesses some library functions. Okay, let's go on to bubble 3, where we get to sort of clean up some existing return functions. Okay. Or no, yeah. Okay, so the bubble 3 is a bunch of existing return functions. And our job is to look through them and test them to see if they work, debug the issues with the program using tests written for each. Okay, so we have a bunch of inputs, and there are all these. The output is just a console log statement. There's no user interface because we're just writing like some background functions, library functions. But all these console logs are the test for it, which is always a good idea before you actually publish it. And if you just hit run when you get here, it's going to have 9 different outputs, but the first 3 are from this first function and so on. So while we're testing, we need to know which 3 are there. We could just comment out, but I don't want to confuse. I think that might mess stuff up if you haven't commented out before. So we'll just keep track of which of the outputs we're actually testing with. Okay, so this function is even, is the name of it, decides if a number is even. Okay, it expects a number as an input, and the name of that variable is called number. And is a number to decide is even or not, and it's going to return either true or false. Okay, again, any function that's like is something is probably going to be a Boolean. Okay, so is 10 even? Let's run this and see if it works. Okay, the first one, 10, so their outputs are concatenating the actual question with the result. Okay, so is 10 even? True, it is. Okay, so it works there. Is 5 even? False. Yeah, so that's true. And is -2 even? I guess negative numbers have a even odd quality, I guess. So then that would be even. Okay, first function works. Let's look at the second one. Is odd. Is odd. Decides if a number is odd. Again, takes a number as an input and returns a true or false. Okay, so this is the second three of the console outputs. Okay, is -2 even? True. Is negative, wait, no, that's it. It's these. Is 10 is odd, false. 5 is odd, true. -5 is odd, true. Okay, great. Those work. Okay, and the last one is between, expects 3 parameters. The one, okay, decides if a number is between 2 other numbers. Okay, the first input is number. It is the number to be decided on. The second number is the low. Or the second input is called low. It needs to be a number and the lower of the range. And the last one is called high. It is also expecting a number and is the high end of the range, and it's going to return either a true or false. Let's see what's happening here. Okay, 10 is between 0 and 5. True. It is not. Okay, and 10 is between 5 and 10. True. 10 is not between 5 and 10. Okay, and 10 is between 15 and 20. Also returns true. It is false. Okay, see if you can work through, or go ahead, work through this and change or fix the function so that it works. Think through the logic of the compound conditionals, the ands and ors, and what you are checking for. This is a simple solution that might be complicated or you might not see right away, but work through the conditional and you should be able to fix it. Okay, this is the point of testing the return functions. You know if it's broken before you publish it. All right, this is the type of question that they would put on the AP test, where you get a little bit of program code and you have to explain what line of the code is broken, or how you would fix it, or how would you replace line 9 from this code to make it work, or something like that. So you do need to be able to kind of just mentally debug things. But just generally, something testing for, is it between 2 numbers? It needs to be higher than the low end of the range and lower than the high end of the range. Okay, every number is higher than the low or lower than the high end. That's all numbers. Okay, in order for something to be between, it needs to be and. So all you need to do is switch the center part of that conditional to an and. It must be both of those things in order to be true, or correct, I should say. And now we try some outputs, and okay, we get all falses. Is 10 between 0 and 5? It is not between 0 and 5. 10 between 5 and 10? It is not between 5 and 10. And 10 between 15 and 20? It is not. Okay, so there you go. Okay, a function like this seems sort of ridiculous when you're sending it literal numbers, like hard-coded numbers. You just, understanding base 10, or really anything, being able to look at it is not between 0 and 5. But that's not how you would use these things. You would always be sending variables or the results of return functions or something as the parameters. So this function is used as the program runs. It's checking things that could change. The number 10, the number 0, and the number 5 don't change as is. Okay, so let's go on to bubble 4, and we get to debug some more return functions, and we're actually nearly done for today. Also, before I forget, I need to figure out some more stuff about the last due dates of the semester while people are still somewhat paying attention. So the last, I could have brought this up at the beginning, but your attention is super useful here. So yeah, the last assignment is going to be the most previous one, the lesson 4, but it's just going to be due. I'm just going to grade it once. There isn't going to be time for redo. So get it done. Okay. Everything is going to be, I guess, graded at the end of tomorrow. Okay. So get it done. We'll, yeah. So the 25th is actually going to be the last day for anything. Okay. The, like I said, lesson 1 through 4 that we did last Thursday, you need to get it done before the end of Tuesday. Because that's when I'm going to stop accepting things. Okay. I think a week is plenty of time to do that lesson 1 through 4. So, I'll put something up more clearly explained on there, but, yeah, so look for that. Okay. Bubble 4, some more return functions. Okay, so let's see what we got. We've got a function called getLetters that receives a string. Okay. Well, we have all these other functions, but these are clearly return functions. Wait, do they say return? Yeah, well, they're return functions because they say return, which means it's not the main program. Okay, so our main program is this function called getLetters. It returns a list of letters. Okay, its input is a string that needs to be either all consonants or vowels, and literally, so case sensitive, even though it's all, is it all built in? Yeah, it's already written, but this is a concept that a lot of people missed in the last one, just a simple bug and not matching case. Okay, the second parameter, okay, the first parameter is which type of words, all the words, all the letters, just consonants or just vowels. The second one is a Boolean that asks, do you want the uppercase one? Okay, it's going to be either true or false. When it's called, it needs to be sent true or false. But in the function definition, that true or false gets assigned to the parameter named upper. And there you can see it's used as its own conditional. Okay, normally in this spot, we would have, if, and really this is a short form of writing out if upper double equals true. Okay, that's how we would normally see it, but you can use a variable or a return function that equates to true or false as its own condition, like by itself, because upper is either true or false, it is a conditional. And so you don't need to write it out like that. But you can, it still works. Okay, so it receives upper, which is either true or false, and that's this. We saw this last time with the nested conditionals, where this big main conditional, or there's got to be another term besides nested, but this first main conditional is checking which type of letter set you want, either all consonants or vowels, and then within each one, it's checking if the call wants it to be uppercase. Okay, and it's returning the entire list, whichever, or calling the return function which will return the hopefully correct list. Okay, let's see what happens when we run it. I'm guessing it's not going to work perfectly. Okay, so all uppercase, that does seem to work correct. All lowercase, that does seem to work correctly. Consonant uppercase does not seem to work. It does seem to be just the consonants, but it is clearly the lowercase. And consonants uppercase, consonants lowercase. Again, also consonants, but lower or upper instead of lower. Vowels uppercase, it's got some vowels, but they're lowercase. And vowels lowercase is undefined. Okay, so the last three or four, the last four of these function calls or these console log statements are not getting the correct response. Okay, your job is to dig through the get letters function and figure out what's actually being sent. It does seem like, okay, so consonant uppercase is calling get letters, sending it consonants, which is what it says it's want, and true for uppercase, that's what it wants. Okay, consonants lowercase is calling consonants, lowercase is false. Vowels uppercase, vowels true, vowels lowercase, vowels false. So it's not the function calls that are wrong. They've not put in the wrong Boolean for the second value or mix things up. The problem is in the main conditional. It's sending back the wrong things. Okay, go ahead and dig through that and see if you can figure out the solution. This is at least a couple minutes to go through. Okay, work through this conditional and see what they've done wrong. Ready, go. Go ahead and do that. Here we go, folks. All right, so let's take a look at this. We've got the main conditional, or the large if else if seems to be right. Okay, if they send consonants, well, the ones that worked were still running. Okay, the one that worked was all uppercase. So all and uppercase return the correct one. All and lowercase return the correct one. So it's not these issues. Okay, the next one was like this. The next one was so all uppercase and all lowercase works. Consonants uppercase and consonants lowercase seem to be switch. So this one is if it's consonants. If it's uppercase, we want this one, but it's calling consonants lower. And the else is calling consonants upper. These are switched from the correct order. Okay, and I go like that. And okay, so what I said about return functions or return calls ending a function, you could see if you ever had one condition that had two returns, it could never be the other one. Okay, let's double check this one, that middle pair. Okay, consonants uppercase seems to have fixed itself, or we fixed it, and consonant lowercase seems to have fixed itself. Okay, the next one is if it gets to vowels. Here's a thing to notice is their initial if else is if all letters, else if consonants, else if vowels. It doesn't end in an else, which, I mean, the code is pre-written, but it is good for something that's checking against a specific input to end in an else if, because if somebody typed it wrong, it would return this last part, even though they typed it wrong. But either way, we have no issue with that in this one. Okay, if it's vowels and we send if upper, meaning if it's uppercase, we're returning vowels lower, which is wrong. So clearly this needs to go in the second part, which is for the lowercase ones of each category. And this one, it's calling vowel upper, but vowel upper is just a function that runs. It doesn't return anything. Okay, so we actually need to turn this into a return function and send it back that way. And I think this should work. We're only worried of the last one. Okay, vowels uppercase and vowels lowercase. Okay, so we fixed it. How exciting. And let's go on to bubble 5. This is wild. There we go. Okay, so the lesson 7, that doesn't make any sense. Oh, okay. All right. So the lesson 7, bubble 5. Okay. Program is being designed as a simple list library. Okay. Write tests to make sure the function works. Then write the second two functions so that they pass the test. Pass the test written. Okay, so not clear on that yet. Okay, so we have a function named fill. Okay, creates a new list of the length given with the same value repeated. Okay, the length is the length of the list to create, and the value is what you want in the list. Now, this actually is kind of useful. There are times where solution to the challenge or something like that is what, how many of something in a row or checking whatever. And you'd want to start with a list of all zeros and change specific ones and then check what happened at the end or what the result was. So creating a list, not an empty list, a list full of a specific number of a certain thing so that you have a space to change it is actually kind of useful, because if you have an empty list, you can't like set the properties or set something at an index that doesn't exist yet. Okay, so if you had a list, you wanted to keep a list of how many people were each age, and you wanted it to end up being a list with the number of people from a group of an age at that index. So, index 20 would be how many 20-year-olds. If you can't increment that specific index, guys, please stop talking. You can't increment that specific index if it doesn't exist yet. So you might want to create a list of all zeros so that you can change one of them, out of order or without just doing an append. And that's what this one does. It's called fill, receives a length, which is how many times it needs to do something, and value is what you want in the list, and it is a return function. Okay, write 3 different tests for this function. Okay, it's just going to be a console log and 3 different console logs that are all calls to that function, which is not in the function definition toolbox. It's not a library yet, because what we're doing is writing a library. So you're going to do this for all 3, sending it values that make sense in the program. Okay, we'll just go ahead and do this first part right now. It should be pretty short to write 3 function calls to double check an output. Okay, you should probably try it with different data types for the second one. The second parameter is what value you want repeated a certain number of times, and having different data types is useful in this case. Okay, so let's have a list that has, I don't know, 4 zeros in it. Let's create a list. Let's try a list that has 9 stars in it. Oh wait, I need to separate the parameters by commas and close parentheses. You can just bring in the function call, of course. And let's have one call, or it's called fill. Let's send it 15 falses, which is also a useful way of using a pre-filling a list where you just set everything to false if you have 15 different things. Oh wait, there's all those other console statements. So we're only interested in the first 3 here. Okay, so we haven't used a ton, but there are reasons why, like I explained a second ago, why you would want a list full of something before you're even programming. If you had, like, there's, what did I say, 15 of them here, they exist and you could change each one at any time, where if you started with an empty list, you can't access or change things at indexes that don't exist yet. Okay, and so there we go. We have some functions that show the output. Okay, second one returns a copy of a list that is provided, or that you provide when you call it, with each value multiplied by a given number. Okay, so it's returning a new list, a copy. It's not changing the original list. You send it a list and a number to be multiplied by, and it returns that new list with each number, increased. Okay, so you have the format, the basic format for a return function here. Go ahead and see if you can figure out how to create that second list. Well, it is already the list there, but using the parameters, loop through. Okay, that's a big hint, is that you're going to loop through. And just to set a timer, this is probably like that. That time. Okay, so that's what we're working on. This is what we're working on. Okay, so we get a list and a number to like its multiplier. So we need to go through a list. We want to do something, whatever lists we get sent, we want to return something the same length. So we're going to list.length loop, and each time through, we're going to append something to our empty list called return list. And that list called return list is going to get whatever was in the first list, the list given to us at that index, multiplied by whatever number gets sent. Okay. And so once it gets to the end of the list, it will have appended all those items by whatever other number gets sent as a second parameter. And so this is the middle three. Okay, 1, 2, and 3 by 2 is 2, 4, and 6. 10, 20, and 30 by 5 is wait, does it return? Oh, it returns a list, but it's concatenating it. Plus, oh, because weird. If you concat a list, it comes out like that, apparently. Okay, but either way it works. -1, -2, -3 by 3. There you go. And then that's good for this one. Okay, and the last one that we need to write in our super generalized return function parameter situation returns a copy of the list, but given in the reverse order. Okay, this is actually, what's up? For this one right here. Okay. There is loop through the list given, and for each one, multiply each element that we check by the number, add it, append it to the return list, and there you go. Okay. So the last one here returns a copy of the list. So it's returning a new list. Wait, yeah. Return list. We are going to return list. And we need to write some code that will take a list and create another list, the return list, with the exact same elements, but in reverse order. Okay, you might not know how to loop through a list backwards, but that can be useful. Well, maybe necessary. See if you can figure this out. Okay, this one, not having seen a loop backwards, or backwards loop, I mean, could hold you back on this one, but yeah, give it a shot. Oh, that's not good. It's got dumped from the back screen. That might not be useful. All right, well, I guess we're front screen only for a little bit. Okay, so this is an important concept in programming. Okay, looping through a list forward versus looping through a list backwards. Let me put this out in space real quick. So if we have a regular loop, which eventually will show up, if we have a regular loop and we want to loop through an entire list, okay, we want to, okay, we want to initialize our counting variable at 0. That's the first element we want to check. We want to do the loop however many elements there are, or we want it to stop when we want it to continue so long as the counting variable is still less than how many elements, meaning it will stop one before however many elements there are. Okay. And then we want to increment each time through, increment by 1. So we hit every element in the list. We do a loop that many times. To loop backwards, you need, what do we want to start at? We want to start at the last index, which is list.length minus 1. And we want to continue so long as I is greater than or equal to 0. Okay, we're starting at the end. The first element we're checking, our counting variable, the letter I, we are starting at the end of the list. That's the first one we're going to check. And we're going to continue so long as we are at or higher than 0, meaning we are either looking at one of the items in the list or 0. And that's what we want it to end. We never want it to go to -1, but that means that instead of going up by 1 each time, we need to go down by 1 each time. So you can either do I minus minus, that's down by 1 each time, or I gets I minus 1, the way we've done it long form. I gets itself minus 1, which might look kind of weird in our this particular typeface. Let's see if I can make it look any better. Why can't I ever do that? Okay, so yeah, so this is decreasing. We're starting at the end of the list. The first element we're checking is the last element in the list, list.length minus 1. We're going to keep cycling as long as our counting variable is greater than or equal to 0. And each time through the loop, I'm going to make it I minus minus. If you don't switch these different parts, you can create an infinite loop. So if you just did, we're starting at the last one, we want to continue so long as we are greater than the list dot or less than the list dot length, and keep going up 1, it's not going to run the loop. And if you leave this as plus plus, it's going to go plus plus forever. It's going to be greater than or equal to 0 forever. If you start at a positive number and keep going up, you will never not be lower than 0. So it will continue forever. So this is looping through something backwards. It is like a very common situation, especially if you're doing any sort of remove. If you're taking a starting list and you want to cut things out of it, you always want to loop from the end, because if you, let's say you have a list with 10 things, if you're checking the third thing and you cut it out, before you go to check the fourth thing, that list collapses. And what was the fourth thing is now the third thing. And when you go check the fourth thing, you're actually checking what was the fifth thing, and you never check that one that collapsed in. But if you start at the end and work back, you find something that you want to cut out, you cut it out, everything you've already checked collapses, and that's fine because you can keep going back down the list, which is essentially what we're doing here, except, I mean, it's not what we're doing. We're not returning, or we're not removing anything, but we are going back through the list. And every time we go to a new element starting at the end, we're going to append it. Okay, because append just adds it. We are taking a list like this and going from the end and putting each one in the beginning in the next slot as we go through it. And the thing that we are appending it to is our return list, the thing we're sending back. And we're going to append whatever we're checking. We're not changing these. So it's list index I. And we can return. Okay, so we already have our console logs working for us. And I can get rid of this since it's not a thing. And so we're concatenating just to have an output for checking. Reverse 1, 2, 3 is 3, 2, 1. And reverse yes, no, maybe is maybe, no, yes. Okay, so that concept of cycling through, in this case, keep adding as we go back around. It's sort of like, I don't know, if you had a lane of cars and you took the last one and moved it to the front of the next one, kept going around. That's what we're doing. Okay, and that is the extent of deliverables for 5. We need to do the check for understanding on 6. Yeah, go for it. And what's up? Let me help you in a second. I'm going to introduce the check for understanding and we will roll. Okay, so the check for understanding for lesson 7, bubble 6, pseudocode reference. Our outputs are all line numbers. Okay, so let's take a look. Okay, the following procedure function was developed to determine if a list contains a negative number. If the list contains a negative number, it should return true. Okay, otherwise return false. So we are checking for has negative number. Okay, an error is made in writing this function so that it does not work as intended. Which line of code would need to be fixed in order for the function to work as designed? Okay, of course you could just guess, and that's not the point of this. The point is to challenge yourself. If you are interested in a 4 or 5 on the AP test, you need to put some time in. Okay, it's not going to happen automatically. And try your best, run through this and see what is actually happening. Okay, the parameter and function name should look familiar. This is the assignment operator, the single equal sign. And other than that, it has one line that is making it break. Okay, I'll give you a minute or two for this. At the right time, jeez. Or more like 1 minute maybe, and then we'll run it. Okay, so let's run through this and see what happens. Okay, we have our function is called check negative. It receives a list. Okay, it's supposed to return a okay, if it has any negative numbers, it should return true, otherwise return false. Okay, so it receives a list.
Good morning, Blazers. May I have your attention for a few brief announcements? On Wednesday, April 2nd,
All right, so this idea of, for Boolean, since this is a Boolean function, having a variable assigned either true or false, then going through and checking whether or not you need to switch it and then return whatever result is at the end is very common. The problem is we are checking for is negative, and our temporary variable for holding it starts out as true. Okay, we loop through and check if it's less than 0, and we assign it true if we have something in the list that is less than 0. The problem is if we start out with an all positive list, it's already assigned to true. It's already assigned to has negative. So if we go through an entire loop of positive numbers, it's still negative and it shouldn't be. Okay, if you're checking for something to be true, your temporary variable has to start out false, because you're only interested if it ever switches to true. Okay, and so that means line 3 is the incorrect line that breaks it. Okay, yeah, go for it. And there you go. All right, so that's it for today. Took longer than I thought, but that's fine. And